Welcome to Spring LIB.
Okay, this is question 28.50. We have a solenoid that's a toroid. And here I've written the expression for the magnetic field of a toroidal solenoid with n terms. And in this question, we're asked the different parts about the magnetic field at different points at different points from the center of this solenoid. So the first part A here asks us about a radius of 12, or a distance of 12 centimeters from the center of the solenoid. So notice that 12 centimeters is going to fall within this circular region here because the smaller inner radius is 15 centimeters. And remember that the magnetic field of a toroidal solenoid outside of that inner region is always 0. So for part A, since the distance that we're looking at actually lies within the space, it's outside of the solenoid. For part A, that with R equals 12 centimeters, B is just going to be equal to 0 because it falls totally outside of the torus. Part B, we have a distance of 16 centimeters. So that's going to be 0.16 meters. And now this does fall within the torus. So we know that the magnetic field will be non-zero. So we want to use our equation up here to solve. So we can solve for the magnetic field just by plugging this in. We know that there are 250 turns, so I'm going to plug that in here. We know that the current is 8.5 amps, and then this R here is going to be 0.16 meters. So we're just going to plug all of that in, and we get 2.66 times 10 to the minus 3 Tesla for part B. Now for part C, we have a distance of 20 centimeters. And now this again is outside the torus. So this is now, we're totally outside of the outer radius. So again, outside the torus, the magnetic field is always just equal to 0. So the answer to part C is just going to be B equals 0.